Today we're doing our last section on this topic, which is the graphs of our trig functions. We're only going to be doing the graph of sine and cos, not tan at this stage. To draw the graph of y is equal to sine theta, we're going to start like we start with most of our new graphs, with a table of values. So I have chosen some angles in here, which is for our theta, and they're increments of 30 degrees. And I'm going to use my calculator to find out what sine of each of them is. So sine of 0 is the first one, and that is equal to 0. Then I'm going to do the next one. Sine of 30 is equal to 0.5. Now keep going. Sine of 60 is equal to 0.87. Sine of 90 is equal to 1. Sine of 120 is equal to 0.87. And you will find once you've done a few of these, there will start to be a bit of a pattern. The next one will be 0.5, next one will be 0. Then they're going to have the same decimals, but we're going to head into the negative side. So negative 0.5, negative 0.87, negative 1, negative 0.87, negative 0.5, and 0. You can check those on your calculator. So once we've got the table filled in, we want to use that to sketch the graph. The angles in degrees are on my x-axis, so down here, and you can see them all on there for you in increments of 30 degrees. And our y value, you can see if you look through the y values, the biggest y value we have is 1, and the smallest is negative 1, which is why I don't need very high numbers here on my y-axis. So now I'm going to plot them. At 0 degrees, y is 0, so a dot on the origin. At 30 degrees, it's 0.5, 60 degrees is 0.87, 90 degrees is 1. Then it's going to come back down again. 120 is 0.87, then 0.5, and then 0. This is where we go into negative numbers. At 210, we're at negative 0.5. 240 is negative 0.87. 270 is negative 1. And finishing the last few off. Now this is a curve, so make sure when you join up those dots that it is curving through them all. And there is our graph of y equals sine theta. Now this pattern would continue. It is a wave. It would keep going in the same pattern if I was to keep going past 360 degrees. And it would also, if I went to the left into the negative numbers, it would continue in the same pattern going that way. Let's have a look at the cos graph. So again, use your calculator to get the values, but we're doing cos of 0, which starts at 1, and then cos of 30 degrees, and you'll see a lot of the same decimals start to show up. Now I won't type every single one in the calculator on the screen for you. The rest of the numbers that you should get are these. Oh, I think I've missed one. Let's go back here for a second. Missed one there. There we go. Okay, so once you've got your table filled in, let's plot it just like we did for the sine graph. So when the angle is 0, y is equal to 1. At 30 degrees, it's 0.87, 60 degrees, it's 0.5, 90 degrees is 0. Then into the negative, negative 0.5, negative 0.87, negative 1, negative 0.87, negative 5, 0, 0.5, 0.87, and 1. And when you join it all up, it looks very similar to the sine curve. Has the same waving pattern that will continue to the left and the right if you wanted to keep going. But the only difference is that it starts a little bit further along. We call it a 90 degrees phase difference. It's just moved along the sine graph. So if we were to start the sine graph here, that would be the cos graph. So it's 90 degrees further along. Okay, so you need to be able to draw the sine and cos graph, and there's some words that you need to know on the next page to describe them. First of all, amplitude. Amplitude is half the distance from the highest to the lowest points. It is actually referred to as the maximum displacement of the graph from a reference level. So in the example below, the reference level is the x-axis, and that's going to be for our graphs as well. So from the x-axis, it's the maximum height that it gets to above the axis. So looking back here at our sine graph, this here is my maximum height, and it would be an amplitude of 1. Looking at the cos graph, its maximum height, we could draw it here or down here at the end, it also has an amplitude of 1. The next word that you need to know is the word period. The number of degrees on the horizontal axis, it is the number of degrees on the horizontal axis taken to complete one cycle. It is sometimes called the frequency, or in science you'll hear it called the wavelength. So this picture that you've got here, doing this complete rotation of the curve, that is one period of the graph, and after that it's just going to repeat that pattern over and over again. So what we've drawn up here for both of these graphs is one period. So the sine graph has a period of 360 degrees, and so does the cos graph, because after 360 degrees they'll start repeating again. Okay, in our examples we want to read some things off of our sine and cos graph. So question 1 says use the graph of y equals sine theta to estimate, part A, the value of sine theta if theta is 250 degrees. So what you want to do is you want to use your graph. It's said to use the graph. You want to find 250 degrees. Now be careful with this scale. We've got numbers going up by 30 degrees, which means a little line in between is 15. So 250 would be just slightly to the left, because that little marker in the middle would be 255. So 250 would be about there. So I'm going to draw a line that comes straight down, and then a line that comes horizontally across. Whoops, that's not very horizontal. Let's fix that ruler. Straight across. Now we need to try and read off what y value that is hitting over here. So looking at the scale on our y-axis, they're going up or down by 0.2. So directly in the middle of the 0.8 and the -1, that's going to be my negative 0.9. And so halfway in between that is going to be negative 0.95. So sine of theta, when theta is 250 degrees, is going to be approximately equal to, I should use an approximately equal to sign there, minus 0.95. Now we've been asked to do this on our graph, so if you're doing this on your test, I would expect to see those lines so that I know that you've read it off correctly. But you can, of course, check how close you are on your calculator to make sure you haven't made a silly mistake. So if you type in sine of 250, I've got negative 0.94, so it's pretty close. Okay, let's try the next one. Part B says find two values for theta for which sine theta is equal to negative 0.3. So that negative 0.3 is the y value. So on the y-axis, let's find negative 0.3, which will be directly in between negative 0.2 and negative 0.4. And we want to draw a line coming across. And we want to find the 2 points where it hits my curve. And then I need to come upwards. So it hits the curve there and over here. So I don't think we could reasonably estimate to any further than maybe the nearest 5 or maybe even nearest 10 degrees. Our scale is not very good. These are estimates. So for this first intercept here, it looks like it's just slightly past the 1, or maybe it should be slightly on. it's pretty close to the middle between that 180 and 210 line. So that's approximately 195 degrees. And the other one looks like it's pretty much on the line right in the middle as well, which would be about 345 degrees. And you could check those on the calculator to see how close you are. But as long as the lines that you've drawn on there look reasonable, that's how I would be marking them. Question 2 is about the cos graph. So part A says, find the value of cos theta if theta is equal to 50 degrees. So use your ruler, it helps keep things way more accurate. 50 degrees will be just slightly past that little middle line there, coming straight up and straight across. Okay, so 0.7 would be there, so it's going to be 0.65 approximately. So cos 50 is approximately 0.65. And the next one, find two values of theta for which cos theta is equal to negative 0.6. So with your ruler, negative 0.6 is down here. We want to draw a line coming across till it intersects the curve in both spots. And then we want to go vertically and try to read off these measurements. So that first one, it's between the 120 and 135, so I'm going to say that that's approximately 130 degrees. And the second one is just a little bit before the 240 line, so that's at about 230 degrees. Okay, question 3, it asks us to use the graph of cos theta. So using the graph to state whether the following is true or false. So cos of 70, I want to know approximately what that's equal to. Cos of 70 degrees is about here. So if I draw that line there and across, okay, that's at about 0.35. Cos of 330 is 330 right on that line there. That's going to be approximately equal to 0.9. Oops. Okay, so we are trying to determine whether that statement is true or false. Is cos of 70, which is 0.35, is that less than 0.9? Yes, it is, so that would be true. Okay, trying the second one, cos of 150. Cos of 150 is going to be here. So we need to know that value, which looks like it's going to be minus 0.85. And the second one is cos of 220. Cos of 220 is about there, down and across. So remember, it's about which one is larger. So that's about 0.75 minus negative 0.75. So is negative 0.85 greater than negative 0.75? No, it is not, because in negative numbers, that's smaller, isn't it? So that is actually false. Okay, so that's what you need to do for this last exercise here. You may find it helpful to use the graphs that we've drawn in the booklet here. The ones in the textbook don't have a very accurate scale.